Hello guys and welcome to today's class on fluid mechanics. Alright, so in today's class we are going to be doing this small derivation on fluid mechanics. Alright, so the question says, show from first principle that Reynolds number is given as 4 times discharge all over pi d times nu. This symbol is called nu, which means kinematic viscosity. Alright, so where Q is given as a discharge, D is diameter, Re is the Reynolds number, and of course, nu is the kinematic viscosity. Alright, so the question says we should show from first principle. So first of all, let us understand what is the Reynolds number. Reynolds number itself is equal to the ratio of inertial force, that's Fi, ratio of inertial force all over the viscous force. Okay, all over viscous force Fv. So what is the inertial force and what is the viscous force? The inertial force itself, Fi, is equal to rho times L squared times V squared, whereas the viscous force itself is equal to mu, which is dynamic viscosity, times L times V. So this is our viscous force and this is our inertial force. So if we are now to compute the Reynolds number, this simply implies that Reynolds number is equal to, we said, inertial force divided by the viscous force. And this is our inertial force, which gives us rho times L squared times V squared all over mu times L times V. Not forgetting that rho is density. So if we do this, now observe that one of these L, okay, cancels this L here, and V here cancels one of the V here. So I'm simply left with what? Rho times one of the L times the V all over mu. Okay, so this and this is off. So this becomes our Reynolds number. Hence, our Reynolds number, Re, is actually rho times L times V all over mu. Now, if we rewrite this equation a bit, we are going to obtain something. Reynolds number is equal to, consider rho all over mu. This will give us rho divided by mu multiplied by L times V. This and this are still the same thing. Now, rho over mu is what is called the inverse of kinematic viscosity, okay, where the kinematic viscosity itself, which is nu, is actually the ratio of dynamic viscosity all over density. Kinematic viscosity is the ratio of dynamic viscosity towards density. So, which means if I have density all over rho, it means it is what? The inverse. So this simply implies from here, if I invert this, density all over mu, it means it's going to now be what? The inverse of kinematic viscosity, 1 all over nu. So I can have this. So density over mu is simply 1 all over nu. So which means the whole of this can be replaced as 1 all over nu. That will simply make my Reynolds number to now be equal to 1 all over nu multiplied by L times V. So this is simply equal to L times V all over nu. From here, of course, 1 times everything here remains L times V all over nu. So we have this now. The dimensions L depend on the given geometry of the property given to you. Okay, it depends on the given geometry of the property. If the geometry of the property is linear, then we use L. But if the geometry of the property is circular, then it means we are going to be needing the diameter of that geometry. So if it is circular in shape, it means we will need diameter, and hence the Reynolds number can also be written as Re is equal to, in place of L, it becomes D times V all over, or simply use small d times V all over kinematic viscosity. So this can also go for, okay, circular objects. Alright, so if the geometry that was given to you of the given object is circular in shape, it means we will need the diameter. Hence, the Reynolds number can be altered and the length can be replaced by what? Diameter. Same thing happens here. This can also be written as rho times d times v. So we can also write this as rho times d times v all over mu. Should in case the geometry of the object is circular, then we will need diameter. In place of the length, we can replace it with d. All right, so we have this now, and the question says we should show that Reynolds number is 4q all over 4 pi d times kinematic viscosity. Now, the first thing that comes into your mind is the word discharge. Q is discharge. Discharge itself, discharge Q is equal to area times velocity. So I've done a video on discharge. Do well to look up the video for proper understanding. All right, so but discharge is given as area times velocity. What is now the area of this given shape? Let's say it is a pipe that has a diameter. Then what is the area? Where area itself, A, is equal to what? Pi all over 4 times diameter squared. This becomes the area of the given shape. If that is the case, it means now that I can rewrite this charge to be equal to, in place of area, this becomes pi d squared all over 4 times v times velocity v. Okay, so pi d squared over 4 is the area times what? Velocity v. And from here, if I cross multiply, 4 can multiply q. This simply implies that 4q is equal to, I am left here now by with pi d squared times v. So if I have this, the next thing I should be thinking of doing is what? Look for the value of velocity v. Let's now substitute in place of v in this equation. So we'll make this subject of the formula from here. If you do that, this simply implies that dividing through by pi d squared will give me what? V. Therefore, v is equal to 4q all over pi d squared. This gives me my velocity. If this is my velocity, then in place of velocity here, put in this value for the Reynolds number. Therefore, Reynolds number, remember, we obtain to be what? 4d times v. So you have d, okay, let's say d all over kinematic viscosity times velocity v, which is here. D over this times v is still the same thing as this. So this is equal to d all over kinematic viscosity times, what is now v? V is given as 4q all over pi d squared. So we have times 4q all over pi d all squared. So if this goes on, we are now going to have d times 4q. Everything here becomes 4d times q all over, multiplying everything under here as well. I have pi d squared times kinematic viscosity. So notice here now that d can strike one of these d under here. So I'm now left with Reynolds number to now be equal to, remember, if d strikes one of the d, then I'm left with 4q at the numerator, which is 4q all over, then at the denominator, I have pi times d. One d remains here times kinematic viscosity. So this becomes pi d times nu. And that becomes the required proof from what was asked us to do, which is this. All right, so that's it, guys. I hope you find this video helpful and interesting. If you do, please do well to leave your thoughts in the comment section. I will see you in the next video. Thanks and cheers.